Let's now discuss the circuit breaker pattern. The circuit breaker pattern aims to 1. Prevent cascading failures in distributed systems. 2. Improve system resilience and fault tolerance. 3. Reduce the impact of service failures on the overall system. 4. Allow rapid failure detection and recovery. But how does this pattern work? This pattern operates like an electrical circuit breaker, monitoring the flow of requests between services. But instead of being a two-state circuit breaker, it has three states. Closed, which is the normal operation. The requests pass through open when a failure is detected. The requests are immediately rejected. And half open when we test if the service has recovered from a previous failure. To simplify, when a service fails repeatedly, the circuit breaker trips to the open state, preventing further requests. And, after a defined timeout, it switches to half open to test if the service has recovered. Now, there are always challenges and common mistakes. To avoid when implementing this pattern to enhance the resilience and reliability of your microservices architecture. First common mistake is setting the failure threshold too low or too high, which can lead to premature tripping or delayed response to failures. Next is failing to set appropriate timeouts that can result in resources being held unnecessarily or premature request termination. Third, it's the lack of monitoring. Not implementing proper monitoring and alerting for circuit breaker state changes can indeed lead to undetected issues. Then, we have ignoring partial failures. Focusing only on complete service failures and neglecting degraded performance scenarios. Another common mistake is over-reliance on circuit breakers. Using circuit breakers as a sole solution for fault tolerance is simply wrong. Rather, it should be part of a comprehensive resilience strategy, and we'll talk about that in another video. Last common mistake. Failing to thoroughly test the circuit breaker behavior under various failure scenarios can lead to unexpected issues in production. Okay, let us double-click on how to implement this pattern within our now infamous e-commerce solution. Okay, let's apply the circuit breaker pattern to our e-commerce solution and more specifically to the inventory service to better protect the product service. Picture this. We've just received a large shipment of the latest iPhone in our warehouse, and we want to update the inventory to reflect the correct items we have in stock. The first thing the inventory service is going to do is to call the product service to get the product ID for the latest iPhone. The inventory service calls the product service and obtains the product ID. So far, all is good. The circuit breaker from the inventory service to the product service is closed. Some orders are then placed by our customers to purchase the new model, and the inventory service calls once again the product service to ensure the ordered product is the right one, but this time, the call fails. The call is retried but fails again. This breaches our defined threshold and the circuit break trips. After a short timeout, using for example, an exponential back-off logic, the call is retried but fails once more. Finally, after an even longer timeout, using some type of jitter randomization logic, the circuit breaker is reset going to the half-open state, allowing the inventory service to try again the call. This time, we're lucky. The product service responds successfully, and we can close the circuit breaker. However, if the call fails again, then we're going back to the open state to provide additional time to the product service to recover from its failure. Now, as a solution architect or a microservice owner, there are several critical questions to answer when implementing this pattern. When should the circuit trip? How many failed requests within a certain period should we consider for the decision? How do we quantify a failure? What's the expected time or SLA the product service should respond to our request before we consider it a failure? When does the circuit can be closed again? How long after a circuit trip we should try again? How long should we give to the product service to recover? Long story short, there are a few non-trivial questions that must be answered before implementing such pattern. And while the idea of this pattern is fairly simple, it does require us to think carefully on how to prevent a complete system failures by stopping calls to a specific service experiencing a problem. Of course, this opens another set of intriguing questions around how to build resilient systems. Okay, that's all for today. Hit the like button, subscribe, and I'll see you soon.